Before we look at how to use the Autoflight system for an automatic approach and landing, let's look at some additional Autoflight features that can be used during takeoff, climb, and cruise. Let's begin with additional takeoff features. We're in position hold at the end of the runway and have elected not to use the flight director for takeoff. A D-rate to the takeoff thrust has been entered into the FMC during the pre-flight. Takeoff clearance has been received and the thrust levers have been advanced to 1.05 EPR. Engage the auto throttle for takeoff. During the takeoff roll, another airplane in the area reports they are experiencing wind shear conditions. Use of the flight directors here would be a wise choice. After 80 knots, both flight directors can be displayed by pushing the toga switch a second time. Push a toga switch. The flight directors engage in toga for both pitch and roll. If the flight directors were on, and LNAV and VNAV were armed, and airplane speed is greater than 80 knots, you can push a toga switch to disarm LNAV and VNAV. If the toga switch is pushed after the airplane leaves the ground, in addition to the flight director command bars appearing, the thrust D-rate is also removed. Since it would be wise to have full rated thrust in a possible wind shear situation, push one of the toga switches again to remove the D-rate. The thrust reference changes from D-rated takeoff to takeoff. The auto throttle engages in thrust reference and sets full takeoff thrust. After reaching 400 feet, a roll mode may be selected. Engage heading select to comply with the clearance. Now that we have reached the acceleration altitude, use flight level change to accelerate the airplane and retract the flaps. Since your current airspeed is greater than the selected airspeed, the current airspeed becomes the new selected airspeed. Engagement of flight level change also changes the thrust reference mode to climb, resulting in a thrust reduction to climb thrust. Next, increase the selected speed to the flaps up maneuvering speed. At our weight, flaps up maneuvering speed is 213 knots. Now let's review the takeoff. Here is the information learned in a previous lesson. Here is a review of the new takeoff information. Now let's go back a bit and look what happens when pitch modes other than flight level change are engaged after takeoff. Recall, upon initial engagement of flight level change, the speed bug and MCP window reset to the current speed if the current speed is greater than the selected MCP speed. Also, the thrust limit mode changes from takeoff to climb. If vertical speed or flight path angle is engaged after takeoff, the MCP speed changes to current flap placard speed minus 5 knots or 250 knots if the flaps are up. The thrust limit does not change. When using vertical speed or flight path angle after takeoff, climb thrust can be set by pushing the Climb Continuous switch. The Climb Continuous switch sets climb thrust with 2 engines operating and maximum continuous thrust with 1 engine operating. Should level off at the selected MCP altitude occur before a pitch mode is selected, the MCP speed changes to current flap placard minus 5 knots or 250 knots if the flaps are up. Thrust limit does not change. Now that flap retraction is complete, increase airspeed to 250 knots. Comply with the ATC clearance. Now let's engage the autopilot. The right autopilot engage switch is also correct, but for this example, assume the captain is the pilot flying and push the left switch. The autopilot engages in the same roll and pitch modes as the flight directors. If the flight directors are not on, the autopilot engages in the following modes. For roll, if bank is greater than 5 degrees, the autopilot engages in attitude hold. If bank is less than 5 degrees, the autopilot engages in heading hold or track hold. For pitch, the autopilot engages in vertical speed or flight path angle. Now change to a vertical speed climb. Push the vertical speed flight path angle switch. Touch the highlighted area. Engaging vertical speed unblanks the vertical speed flight path angle window at the current rate of climb. Pitch changes from controlling airspeed to controlling vertical speed. The autothrottle takes over airspeed control. Reduce the rate of climb to 1,500 feet per minute with the vertical speed flight path angle selector. Now let's skip ahead to the cruise phase of flight. While on radar vectors to your flight plan route, ATC vectors you around some local thunderstorms. You are cleared to intercept and fly your planned route. Push the LNAV switch. Since you are out of the capture criteria of LNAV engagement, LNAV arms. Approaching the LNAV route, LNAV engages and turns on to the planned route. Now let's skip ahead again and look at the approach phase of flight. We're now on an intercept heading to the localizer, and ATC just cleared us for the ILS approach. Arm approach. Localizer and glide slope enunciate on the FMA. In this airplane, the FMC automatically sets the frequency and front course for the selected ILS approach. When the frequency has been identified, the ILS identifier replaces the ILS frequency on the PFD. The localizer captures if the track is within 120 degrees of the localizer course. On localizer capture, the inbound heading automatically sets on the MCP. Once the glide slope is captured, the missed approach altitude can be set. Set the missed approach altitude for this approach to 5,000 feet. Once both the localizer and glide slope are captured, the approach mode can only be disengaged by pushing a toga switch, disengaging the autopilot, and turning off both flight directors, or, if above 1,500 feet radio altitude, pushing the approach switch a second time. If approach is pushed, the autopilot engages in the following modes. Roll, if bank is greater than 5 degrees, the autopilot engages in attitude hold. If bank is less than 5 degrees, the autopilot engages in heading hold or track hold. For pitch, the autopilot engages in vertical speed or flight path angle. At 1,500 feet radio altitude, the Autoflight system goes through a pre-Autoland test. After satisfactorily completing the test, Land 3, Rollout and Flare enunciate, indicating all 3 autopilots are engaged and operating normally for an automatic landing. If a crosswind is present, runway alignment occurs between 500 feet and 200 feet radio altitude. Runway alignment is when the airplane changes from a crab to a slip. There is no enunciation when the airplane aligns with the runway. Between 60 and 40 feet radio altitude, flare engages. At 25 feet radio altitude, the autothrottle begins retarding the thrust to idle. About 2 feet radio altitude, rollout engages and the autopilot controls the rudder and the nose wheel steering to keep the airplane on localizer centerline. Selecting reverse thrust disconnects the autothrottle. When disconnecting this way, the ICAS message does not display and the caution light does not illuminate. Finally, before turning off the runway, disconnect the autopilot with the disconnect switch on the control wheel and cancel the warning with the second push. Touch the highlighted area. Re-engaging the autopilot or second push of the disconnect switch are the only ways to cancel both the ICAS message and the oral warning. This completes the instruction section of this lesson.